All right, so we're going to start with 3.1, which is imaginary numbers. Imaginary numbers are kind of awesome. We're going to start with an algebraic definition. Okay. And in order to do that, we're going to start with that equation. Okay. Can you think of any values of x that you can plug in here that will result in a -1 answer? Not really, because a negative times a negative is a positive. So you'd have a positive result. So you're like, no solution? Question? Okay, so even if you do negative parenthesis, okay, even if you do this, a negative, right, the squared means, oh, but then it's not the same thing. So, true, because if you have this, okay, this negative is not included in the square, so this statement is not actually the same as the one that we started with. Okay, so this is the predicament. So the mathematician was like, I need to figure out how to solve this, and I wish I could tell you the name of the guy right now, but I can't, so I'll look it up. So he said, I want to have a solution to this. So I'm going to invent a new kind of number. I know, right?
What's the point of that?
Okay, there's actually a really good reason to have imaginary numbers, and I'll explain that momentarily. So what we end up with is plus or minus. Okay, so when I square root, I actually get plus or minus on the other side. And this. Here comes the definition. Root -1 is kind of tedious and kind of messy to look at. So that's the new number. Root -1 is what we are going to call I. It's like a substitution. It's just a prettier way to write root -1. Yes, I is for the imaginary number. It's kind of like x. It's just a letter, but instead of writing root -1, I write I. And so this solution is plus or minus I. Much prettier to write. Faster also. Okay, so that's the reason this number was invented, because we needed to have a way to find the solution to this equation. All right, so this over here, this is the definition. I is equal to root -1. I would like to find what I squared equals. Okay, I squared is, yes, right? It's kind of like this, where you multiply the same thing twice. I squared equals root -1 times root -1, which is kind of like this, but the root and the square, they kind of cancel each other out, and so we end up with I squared equals -1. Now this isn't the initial definition, it's sort of an extension, but those two boxes, you have to know that, okay? You have to know that I represents root -1 and I squared is equal to -1. Okay. Now we're going to do a little Venn diagram here, but I'm going to do it in terms of squares. Okay, two squares that don't overlap. Real numbers. complex numbers. Okay. Complex numbers are the numbers that have an I. They are separate from the real numbers. Okay, so when I say real numbers, I'm talking about everything that shows up on our graph. Negative infinity to positive infinity. Those are real numbers. Real. They show up on the graph. You can actually see them. Complex numbers, it's like a different set of numbers. Okay, they don't really overlap. So this is called a complex number. Okay, a complex number. This is the format. A plus BI. A is the real part. Real part. 1, 2, 3, 4, 5. Okay. B, I is the imaginary part. This is the general format for how we write our answers. This is called standard form. Okay, so this is how we want to write. Okay, this is standard form. Okay. Okay. Examples.
How big are the examples?
3 lines. So I'm going to put 2 examples, and that's how much space I have. I'm going to write 2 examples there. So they're pretty small. Okay, so we're going to start with root -9. Okay. This is where, on a normal year, I know you would get a lot of practice with this in geometry. It was not a normal year, so we'll see where this takes us. The first thing I'm going to do, now that's a square root, so I'm thinking about my perfect squares. 1, 4, 9, 16, 25, 36. Okay, perfect squares. And I'm going to write -9 as -1 times 9, because 9 is the perfect square. Now, because this is multiply, the radical actually just goes around both of those numbers, and then you can evaluate or simplify. So instead of writing root -1, I'm going to highlight it because that's my definition. Instead of writing root -1, which is kind of ugly, I'm going to write I. It's just a different way to write it. And then root 9 is 3. Now, typically, we put letters after numbers. So the answer is 3I. I's are fun.
If it's an imaginary number, why does it matter in real life?
Okay, no, it's a really good question.
Why are we
Is this gonna be on our
Okay, root -27. So as I'm thinking about splitting up my 27, I'm thinking of my perfect squares, which is 9 and then 3. So check those multiplication tables. You need to know that 27 is 9 times 3 and that 9 is the perfect square. So the radical follows through, okay? And then we simplify each part. I, 3, that part doesn't simplify, so you leave it. Now, the general format, 3 root 3. The number sometimes goes in front of the letter, but be very careful that your I does not slip underneath that radical, okay? So a lot of times you'll see this part, and then you'll see the radical written after it. They're both correct, okay? Because it's multiplication, which is commutative. You can multiply them in any order, and it still works, okay? But you might see it written either way. Just be careful that that I doesn't slip underneath your radical. Okay, so I'm just going to highlight this part because that's the definition that I used in order to simplify. Okay, about the same amount of space, maybe one more line. I'm going to do 2 of them on the same row here. Okay, so we're going to do root -5 times root -5. Okay. All right.
I liked it better when we dealt with real numbers. Why do we have to learn
The
that?
imaginary unit
Eyes are they're so fun.
The imaginary unit allows us to find solutions for many equations.
Yeah, but what if the solution isn't supposed to be real? It's you just wait, no solution. Can't you just multiply them and put them under one radical?
Oh, almost. Almost. Okay? There's actually a rule that we're going to look at. Okay? So this simplifies, okay, like this. All right? And so this is I root 5, I root 5. So as I'm looking at this, I'm like, okay, Jane said, why can't I just multiply these things together? You can, however, all right, so I've got I times I. So multiplying these things out front, which is I squared, okay? And here we've got root 5 times root 5. So the pieces that are underneath the radical get multiplied together as well. So that is root 25, which is 5.
Then why didn't we just do that first?
Okay, hold on, here it is. I squared as a definition is -1. So this actually simplifies to -5. Okay, so there is a rule.
Real numbers again.
No, that says radicals can only be, nope, almost, multiplied, right? You can only multiply them if, we call this the radicand, okay, that's the thing that's under the radical. The radicand is positive. And so what that means is you have to take care of the I part first before you multiply them together. So yes, you can, but you have to deal with that negative under the radical before you do it. All right, so I'm going to give you a question to try. So root -27 times root -12. Okay. So root negative 27 is actually on the first page. So I've got negative 1, 9, and 3. Can anyone tell me how to split up negative 12? Sure, Margot. Okay, it can be, but what's the perfect square that multiplies to 12? Yeah, so I like to write my perfect squares first just so that it's kind of in order, but yeah, 4 and 3. Okay, because I don't need more than one step here. If you need to do a little factor tree off to the side, do it off to the side. I would expect you to write the step with the perfect squares right here. Okay. I also might expect that you could go from here to almost the answer. Okay? I'm going to do it in multiple steps so that you can see the progression. All right? So right here, there's the definition. So that part's going to simplify as I and I. Root 9 is 3 and root 4 is 2, right? Notice this is all just multiplication between these things. All right, and then I see this really fancy and I'm like, isn't that just 3? Yeah, that's totally fine. If you can do that without writing it down again, then just write 3. Yes.
Would it be the same thing if we multiply the 2 and the square root 9 and then put it down?
Sure.
That's way to square root,
Yeah, there's lots of ways to do this, but I would say that you only want to combine, actually make your numbers bigger when you don't see another choice. Okay? So, I guess I'll just write it like this. Okay? And I'll do this. Okay, so right now I've got I squared times 6 times 3. Right, because I did the radicals there.
Should the I squared be negative?
Hold on, we're getting there. Isn't 3 times 2? I'm just multiplying 2 things together at a time. That's all I'm doing. All right. I squared is the definition. So that is negative 1 times 18, so it's negative 18. All right. Here we go. Now, right, I wrote lots of steps down because I'm not sure how much of simplifying radicals you've seen before. So I'm going to do it again, but I'm going to do it a little bit faster. Okay, negative 1, 9, 3, negative 1, 4, and 3. And I'm just sort of going to, okay, I'm going to leave my radical. Woo. I don't feel like writing it a whole bunch of times. So I'm just going to highlight. There's my definition. Okay. This comes out. This comes out. This is me just organizing what I'm doing. Okay. All right. So from here, I can say, okay, I, 3, I, 2, 3. You don't have to keep writing it if you can match up all your perfect squares from the first step. Totally fine. Okay? So then I get I squared 9, 18. It's up to you how you split up the work. Okay? As long as you keep track of your numbers, find those perfect squares. Sometimes your perfect squares appear as one number. Sometimes they appear as the same number multiplied twice. Okay? You're looking for your perfect squares however you find them. Okay. Last example. Right? After lunch is all yours. Okay? We're going to call this one B. Add. Subtract. Multiply.
Wait, I thought I
I'm just going to write PEMDAS.
some people call it PEMDASler because you're supposed to do it like PEMDAS left to right. And I was just like, okay.
Okay, so those are my directions. Write in standard form. That means A plus BI. Means you have the real part, the imaginary part, and that's it. Nothing extra. Okay? So that's it. That's the definition. Okay? Example. 4 parentheses 2 plus 3i. No, you're fine.
Wait, 2 plus? This is all one equation? What?
It's no. Just write it. We're gonna do our PEMDASler. Okay. Now, what if I said this? Okay. What if I said this? 2 plus 3x minus 2x, 3x. And I said, simplify and combine your like terms. Feel okay?
Yeah.
Yeah.
Same statement, guys. I is like x. It's just a letter.
It is.
I like this.
Yes,
I like
That
this.
makes it so much easier.
it is. Okay. I is just like an x. Okay. So 8 plus 12x minus 6x squared plus 2x. Hold on, I'm almost there. Plus 14x plus 8. The only difference is that x is an I. That is the only difference. Okay, so same rules apply. Distribute, combine the same parts. All right, so here we go. Let's distribute. 8 plus 12i. Okay, minus 6i squared plus 2i. It's just like x. Okay, so I do see my like terms, and I am not above boxing, triangling up my like terms. Okay, now I am gonna go ahead and isn't I squared supposed to be -1? Okay, so here we go. 8 plus 14i. 8 plus 14i. Now this green box is really, I is -1. So that turns into plus 6. That's it. Okay, that's the only difference, is that my answer has to be A plus BI. So 14 plus 14i. Okay, notice that the only thing that is new is replacing the I and the I squared. That's the only thing that's different from what you've already learned about PEMDAS and multiplying and distributing. Whew.